Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 44 of Physics 5054, and yesterday we were doing exercise in which we did 5 questions. Today we are going to do the last 2 questions, that is question number 6 and question number 7. We will start the next chapter, which is measurement of temperature. So stay tuned, don't miss any part of this video because we are starting a new chapter. So if you are not understanding the basic concept of the new chapter, then you won't be able to learn the subsequent topics. So be with me. Let us finish first the final. There are 2 questions in it. Question number 6 has given this uh, figure in which there is a small piston and there is a large piston on which there is a load. Keep in mind that small piston with the area A, this is small a, and this is the large piston of area A and weight W. You have to keep these symbols in your mind, that how we will use these in these equations. So we are applying a force on it. It is pressing down, and this pressure is converted to the larger piston. As a result, it will left a heavy load. So the question has given the diagram illustrate a simplified form of a hydraulic press. A force F is applied to the small piston of area A and of negligible weight. We are neglecting the weight of the small piston. We are not considering that. Write an expression for number 1, the pressure exerted on the liquid by the small piston. Very easy, because pressure is denoted by P and F is here, and there is small a, so you have to write small a. If you are writing uppercase A, then you are wrong, because area A is given as small a. So pressure is equal to F divided by A. In this question, they are making sure that whether you are paying attention to the symbols or not. In the B part, they are saying that the pressure exerted on the large piston. So in this case, there is P and weight is equal to F, because F is W. So here you will write W, and uppercase A is given. So you have to write uppercase A as this one. So this expression for the large piston is totally different in symbol. The concept is the same, but the large symbol, the symbols are changed. Now in the third part, they are saying the force exerted by the large piston on the load L. So from this we can say that W, which is equal to force, and P multiplied by A. There is another small part indicate what becomes the energy used in pressing down the small piston. We have chemical energy in our body, and due to that chemical energy, we are applying a force on this small piston. As a result, that force is converting into energy. So force is converted into energy. Force is converted into energy because energy is required to uplift this load. So, from where that energy is coming from our body, we are pressing this small piston, we are applying a force. We won't be able if we are not having any energy in our body. So, our body energy is applied in the form of force on small piston, and that energy is and that force is converted into energy. Okay, that was a small part at the end written. So this was question number 6. Now in question number 7, they given us these two figures. One is the, both of them are the instrument for measuring the pressure. One is the barometer and the second is the manometer. In both of them, there is a liquid which is called mercury. Here it is also mercury, and in this case, there is also a mercury. So the question is asking, figure A shows a mercury barometer used to measure the pressure, and figure B shows a mercury manometer used to measure the pressure of the gas in container. This is the gas connected to a gas container, this portion. You learn that in theoretical portion. Make mark on the barometer number a point P where the pressure is almost zero. So P will be 876 centimeter and pressure will be zero because the space above the mercury is vacuum. So wherever there is a vacuum, that will be of 76, for example here, so it will be, the pressure will be zero there. So because there is vacuum, so pressure will be zero. So this point will be marked as P, which is 76, which is 1 atmospheric pressure. And the B part is saying a point Q where the pressure is 20 centimeter of the mercury below atmospheric pressure. Ladies and gentlemen, 20 less than atmospheric means 76 minus 20, so 56 centimeter. That will be at 56 centimeter, and that will be somewhere here. That will be Q. Okay, now in C part they are saying mark on the manometer. First was barometer, and the second is manometer. So they are calling us to deal with the manometer in this case. A point R where the pressure is 5 centimeter of mercury higher than atmospheric pressure. So R will be 876 plus 5. So it will be on the 81 somewhere here. So this R will be on 81 and this will be here because 5 above when the pressure is going, so it will move up. So pressure will be increased and we have to add 5 to that and it will be 81. R will be somewhere here. Now the D part, which is the final part of this unit, a piston, a point S where the pressure has its maximum value. So it will be 81 because here the pressure will have 81, here it is also 81, and here it will also be 81. The maximum value on the barometer in this manometer in this case will be 81. Ladies and gentlemen, that's it. And now we are starting our uh, next unit, which is unit number 8, and measurement of temperature. Measurement of temperature is the name of this unit. Uh, Ladies and gentlemen, temperature is important in the study of science because many properties are changing with the change in temperature. Now, to study a material in greater detail, we must be able to measure the change in temperature accurately. Otherwise, we won't be able to study the matter. So, in this unit, you will be able to measure the temperature of an object. Our next topic is temperature and heat. This is a confusing word in our daily life. Those who are not aware of the physics, they are using these two words interchangeably. For example, they are saying temperature is high in the summer times, and also they are saying that today the heat is very high. Ladies and gentlemen, in science, temperature is one thing and heat is another thing totally different. What is temperature and what is heat? We will define that, but before that, temperature can be cold and temperature can be hot. But heat will never be cold. This is the main difference. Temperature can be hot. If the body temperature is high, somebody is having fever, so we are saying the temperature of the body is very high. Now we are going to Antarctic. There is temperature also, but we say the temperature is below 0 degree Celsius, so it is cold. So temperature can be cold or hot as well. But heat is the thermal energy of the body which is flowing from hot body to the cold body. There is a difference. Thermal energy is always flowing from hot body to the cold body. Never it will flow from cold body to the hot body, because heat is a form of energy. Only heat is having the energy to move. Cold doesn't have any energy. So coldness cannot be flow to the hot body. Let me give you an example, then we will define it. If there are two containers, in one of which there is hot water and in other there is a cold water, and if we are bringing this red pen marker is having hot water and this blue is having cold water, when we bring both of them in thermal contact with each other, then heat will flow from hot body to the cold body until both becomes at the same temperature. When they are at the same temperature, then it means now energy cannot flow from any body to the other body. So let me tell you that heat always flows from hot body to cold body. Let us elaborate it with another example. There is an area which is very hot in summer, and there is another area nearby which is cold. In hot area, there will be a high pressure, because when heat is given to the air, they will spread the air particles, and it means that pressure is high. When there is a cold area in which there is particles in the air, they will be compact. So heated area will try to push the colder particles, and as a result the air will flow. That will the blow of air will occur. So it is also like this, that heat always flows from higher high pressure areas to the low pressure areas. Keep this in mind, and it is analogous to the water level. If there is a water at the height, and if they are having a low area, so water will flow from high area to the low area. So now let us define formally temperature and heat. The degree of coldness and hotness is called temperature. The measurement of coldness and hotness is called temperature, is also the definition. Instead of degree, you can use the word measurement. The measurement of coldness and hotness is called temperature. Here I am writing the amount of thermal energy. This is the definition of heat. The amount of thermal energy that can flow from hot body to a cold body is called heat. And that is what I told you, that heat is always flown from hot. So there is a common mistake, that we are using the words hotness, heat, and temperature, but they are totally different. I told you that temperature can be cold. Let me write it so you note it. Temperature can be cold or hot. Ladies and gentlemen, let us tell you that how to measure the temperature. Before discussing the instruments used for measuring the temperature, let me tell you one very important thing, that our sense of touch is not a good estimator of temperature. There are different senses. There is a sense of touching. Let me give you an example and explain it. For example, in cold day, if with one hand you are touching the handle, the knob of a door with one hand, and the wooden portion of that door with another hand, both are at the same temperature. It is not that the temperature where the knob of the door is occurring is different from the temperature which is very in the vicinity of that knob is different. No, both are the same, but our sense of touch is feeling very cold when we are touching the knob of the door, and we are not feeling the wooden portion of the door that much colder, which we are feeling that knob. So what should we do? Because at the beginning of this topic I told you that we have to measure the temperature accurately. So what we will say in this case of the door knob and wooden portion, that whether the temperature is cold or hot, because one is telling us coldness and the second one is telling us hotness. So we won't be able to differentiate between the two. For that purpose, we need an instrument to measure the temperature, and that instrument which is used for accurate measurement of temperature is generally called thermometer. Therm means hotness or coldness. Meter means measurement. The measurement of coldness or hotness. Temperature can be measured by a device called thermometer. Ladies and gentlemen, for different temperatures, we are using different thermometers, and different thermometers are using different physical properties. One thermometer is using one physical property, and another thermometer is using another physical property. So to discuss the measurement of temperature, actually we are discussing different thermometers. Every thermometer is using a specific property, and we have a table here in which compactly we use different properties to create different thermometers. Let us discuss it. Physical property: volume of a fixed mass of liquid. There is a thermometer in which we are using fixed mass of a liquid, for example, mercury. Mostly when you are seeing the mercury inside the thermometer that is used for the temperature measurement of about 96 to 106, in this range, we cannot measure high temperature of 200 degrees Celsius. With this, it will be broken. Let me take the advantage of time and tell you, because I am a certified trainer of CIE. During the training, we went to a laboratory, and the trainer told us that when the mercury thermometer is broken and the mercury spilled out of the thermometer on the earth, you don't have to take it by hand or by any means. There are special teams in the city for the picking of that mercury. I saw myself that many people are putting that mercury on their hand, and they are amusing themselves with the flow of that mercury. It is very dangerous. It can cause cancer. So don't touch if you are not an expert. There is no way that you can remove that. Special teams are having special equipments to remove that mercury. So volume of a fixed mass of liquid, there are two types of thermometer we can create. There will be a fixed mass when temperature or heat is there, it will flow. It doesn't mean that the mass of the mercury is increased. No, the same fixed volume is there, but it is expanding. So when it is expanding linearly, so we are getting the temperature of the body. On this physical property, because while liquid is expanding with the temperature, we can create two types of thermometer. One is called mercury in glass thermometer or alcohol in a glass thermometer. These are the two types of thermometer. The most precise one is mercury in glass thermometer. We will discuss that in the subsequent topic, that why we are using mercury instead of water and other liquid. But here you have to understand that there is a physical property, electromotive force. Now we will discuss this electromotive, which is called EMF, electromotive force. Very technically, we are saying that inside the battery there are electrons and there is a chemical energy which is forcing those electrons to move from negative terminal to positive terminal. The force which is compelling that electron to move from one terminal to another terminal, there is a conventional current which we will discuss, that from positive to negative. But when electrons are invented, then we reverse the phenomena, and that is the change from negative to. We are not concerned in this specific topic whether electrons are moving from negative terminal to positive or from positive, but generally we are saying that motion of electron. Electromotive. Electro means electron, motive means motion. So there is an energy used to move the electron, that is called electromotive, and we will discuss on this physical property, electromotive force, which is called EMF. We are creating thermocouple. There is resistance of a piece of wire. The obstruction, I should say, towards the flow of electron is called resistance. When electron is flowing in copper wire, it is flowing without any resistance. 99.9% pure copper wire is having less resistance, and it will not consume any energy to overcome the resistance. But if we are having other types of wires, so there is a greater resistance. How you will find? Whenever a wire becoming hot, when current is flowing through it, it means that it is having much resistance. That is why energy is lost in the form of heat to overcome that resistance. So a resistance of a piece of metal, on this we will resistance thermometer, and we will discuss that what is resistance. So far we are only discussing the physical properties and different thermometers name. So here resistance, pressure of a fixed mass of a gas. Now how we will find the pressure, the temperature which is produced by the pressure? How we will? There is another constant volume gas thermometer. These are the different types of thermometer. The question can come in the CIE's exam, that on the basis of this electromotive force, EMF, we can create which type of thermometer. They will give you 4 options in which you have to select one of them. So, ladies and gentlemen, memorize these things, understand it, keep it in your mind. It is not a big deal. Easy. I am going to stop it here because we are running out of time. Always my focus is to take 30-minute class. So 1 or 2 minutes less or more doesn't matter, but I don't want to extend my class more than 30 by any means. Thank you very much for watching. Allah Hafiz.